Modern technologists can barely contain themselves. Why? Because there's a whole new way of designing enterprise software nowadays using a microservices architecture. Containers are a big part of this remarkable new paradigm. Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
It's your host here, Eric Kavanagh. And folks, I am so excited to have an all-star cast today. We're going to talk about, frankly, one of the absolute hottest topics in the world of enterprise computing. It does affect the real world too, all those business applications you're running. It affects the future of business, quite frankly. We're going to talk about something called Kubernetes and distributed computing and the concept of state. So what is the state of state? That's my fun little planned words here for today. We'll hear from Jonathan Johnson of Du Jour, Anton Els from HVR Software, and Paul Scott Murphy from a company called WANdisco. And first, let me just give you the sort of lowdown on what Kubernetes is. It's a project that came out of Google, and it's absolutely brilliant. So basically, what Google created in Kubernetes is what I call the operating system for the cloud. So it focuses on container orchestration. And what that means, really, a container is basically a pod that has inside of it a little bit of functionality, like a system process, basically. And if you think about what an operating system does, the OS for PCs, it's Windows, for example, or Linux. For the Mac, it's the Mac OS. Of course, your smartphones have operating systems as well. And the OS has lots and lots of functionality packed into it, which developers then use when they map out their application. So whatever app you have, it's designed, it's compiled, I should say, for a particular operating system. But that diversity and that heterogeneity can be a problem. So it could be a problem for the application you designed. Oh, it runs on Mac, it doesn't run on PC. That does happen sometimes. That's kind of a pain. And Google really thought through the future of computing and realized this is a problem. We don't want companies to have to worry so much about what the OS is on that target machine, whether it's a PC or a smartphone or whatever. And so they developed this thing called Kubernetes, which is absolutely fascinating. It's really designed to enable distributed computing. So it federates compute, basically. You launch a little container, it goes out across the network, it lands on the device, opens up, does its thing, and then goes away. And they're ephemeral too. They're very ephemeral. So they just go and they do their thing and then they disappear. Well, think about how virtualization changed the computing world, right? Because VMware came along, and with with virtualization software, you could really optimize the use of processors, for example. Because back in the day, before VMware, before virtual machines, for example, you just weren't getting that much out of your data center. And someone figured out, hey, if we could find a way to virtualize this, the use of these resources, that'll be very powerful. And so that's what virtualization did. And now Kubernetes is not so much like virtualization. It's similar in the abstract, but it's different in terms of how it operates, but it's a similar concept. And I'll just throw one last comment out here too. Way back in the day, something called the service-oriented architecture is what we focused on in like the 2000s, the early 2000s. And the idea there was somewhat similar. So instead of having these monolithic applications like your SAP ERP, for example, or really any sort of enterprise application that you were running, instead we wanted to basically have what were called services, either coarse-grained or fine-grained services, and then they would collectively come together and do something. So if you think about a service, just to kind of break it down real quick, think about a spell check for your application. Like you have a spelling check dictionary that you run in Microsoft Word or in some other application. That's like a service, basically. It's a fairly coarse service. It's pretty complex, but that's a service. You want to be able to call that from any application so it stands alone, right? So what we're seeing now with Kubernetes really, I think, is the culmination of that vision that we had 20, 25 years ago. It's just now it works really well, and it's very complex. And hopefully Jonathan Johnson from Du Jour is going to be able to explain it a bit better than I did. But Jonathan, tell us a bit about yourself, and we'll talk about state in a minute. Tell us a bit about yourself and what you see in the world of Kubernetes.
First of all, thanks for welcoming me here, Eric. This is great. You touched on a lot of different things, Eric, and that is one of the aspects of Kubernetes is that you're touching on a lot of different topics. Some will call it an operating system for cloud native. Some will talk about it as being a way to scale applications. Some will say it's a operating system for a cluster environment. Some will say it's a way to mesh your applications together into a network. Different people approach Kubernetes from different perspectives. The key thing to remember, though, is going back to the operating system. Typically, when we think about operating systems, we think about them as being something you run on a device, your mobile phone, your laptop, or a blade server in your on-premises data center, or a VMware or an EC2. These are all hosts that have an operating system on them. And what do those operating systems do? They're managing CPU, memory, and I/O. Well, what about performance? Well, that's I/O, and that's CPU. That's also memory. What about security? Well, it kind of gets into CPU, memory, and I/O. All of those things, those are the resources that the operating system is managing. The key difference about why you would call Kubernetes an operating system versus all the other operating systems we're used to is that Kubernetes is still managing CPU, memory, and I/O, but it's doing it across all of they call them nodes. Those are the virtual machines in your data center. So Kubernetes is still managing CPU, memory, and I/O like any operating system does. It just happens to be across multiple machines. But that's the rub. The 8 fallacies of distributed computing is the rub. The fact that you are consciously making decisions saying, oh, okay, I've got this application, and now I'm going to take that application and run it on 2 machines, not 1 machine, but 2 machines, taking your monolith and breaking it up. Now I'm going to run on 2 machines, not 100 machines, just 2 machines. As soon as you make that decision, you've just made your life way more complicated because you are now involving a network, and things are distributed. And those 2 machines need to get to data. Where does that data live? Persistent data, long-term data, more than just ephemeral short-term caches.
It really is fascinating. And if you would, as best you can, explain this key bit of functionality, which I mentioned in the opening here, how in Kubernetes, which of course sits on top of Docker, you essentially obviate the need to worry about the target OS. So whatever OS this pod hits, it's going to work the way it should. How does that happen? Is there a sort of library of functionality that the base of Kubernetes maps against to make sure it executes the way it should on the target device? How does that actually work?
Yeah, so Kubernetes itself, as an operating system, has a set of processes, and you call them the control plane components. And those control plane components are written for different hosts, and you can run them. They're all written in Go nowadays. But the key thing, that's the control plane. The key thing about your applications is that your applications are packaged into containers. What we used to call Docker containers, now they're just containers, OCI containers. So those containers are packaged once, run anywhere. How do you run those packages anywhere? It's the advent of a container runtime engine. Docker has a runtime engine, and there's a new one. Not new, but Containerd is another runtime engine. Cryo, which Red Hat uses, is another container runtime engine. So there's runtime engines out there that can run containers. Those runtime engines can run anywhere. That's the gift. As developers, we don't really care about these runtime engines. They just work for us. As a Kubernetes engineer or people that stand up these clusters, we have to make sure that these container runtime engines are distributed across the cluster. So imagine you have a stack of Raspberry Pis. You can put container runtime engines on a stack of Raspberry Pis with a plexiglass stack, and you have a Kubernetes cluster. You can run your container runtime engine on a laptop, Minikube, Kind. There's a couple different ones out there, Micro K8s, K3s. You can run Kubernetes on your local laptop because you can run container runtime engines on there. And of course, EC2s or Google machines or Docker, not Docker, but DigitalOcean Docs system. There's a bunch of different cloud vendors that all provide container runtime engines with the Kubernetes control plane components. And that's what makes up the working mechanics of Kubernetes. But from a developer perspective, you package your applications in containers, and they'll package once and they'll run anywhere where those container runtime engines are running. That's what makes it so agnostic.
Anton, tell us a bit about yourself and HVR software and how you view Kubernetes as the new foundation for enterprise computing.
Hi, Eric, and thank you for having me on the show. Yeah, this is an exciting topic. So, yeah, I'm a cloud architect at HVR, and to summarize, if you're looking at people are, not just leaving data sitting in the corner anywhere. What people want to do is they move data around and push it into systems where they can get some value out of it. And HVR's has got awesome technology that actually helps you to actually get this data, as I say, fresh from one side to another, so real time, so you can then do whatever you want to do with that data, whether it's analyzing it, slicing and dicing it. So we can help you do that. Now, this is a very interesting topic, and I really like what Jonathan was saying there. And I think one thing I always go is if you start breaking these things down a little bit to the basics, because even though for us, we've been playing with these technologies now for many years. I remember when I started getting into it, I saw this random tweet by someone, and she got me interested in this. I was like, what is this Docker? What is this? I was like doing virtual machines and running stuff on my laptop, and it just took forever to do stuff. And I'm like, this Docker thing sounds really interesting, so let me have a look at this. And 2 days later, I was like, wow, what a thing. I was like nonstop, just looking at this, looking at what it's doing and what you can do with it. And, from running, instead of running like one virtual machine on your laptop, and it takes a lot of resources and everything, you kind of can run multiple containers with various different applications, and they all just use the resources that they need. You don't need all these extra processes running and everything. It's nice and isolated. And I love the example that you use. You can take a few Raspberry Pis, put them together, and you can build a cluster. And people can run, like I've seen people talk about 100, 200, 300, 400 containers that they run on a Raspberry Pi cluster. Who would have thought you'd be able to do that? But with container technology, you can. And I think one thing for me that was, it's always been very interesting, because I used to work and still a lot with, people that's developing and the engineering teams and all of that. And what you find is that everybody needs environments to build on and what they want to code on. And traditionally what you have is you've got the thing where development's busy coding something, they give it to someone else, they say, well, it doesn't work on my environment, and the developer will go, but it works on mine. But if you look at it, they're all using different environments. And what you started doing with containers, bringing container technology into it, is that you build the container once, and you build it to your specification, and you only run your code in it. I think that's one key thing to highlight. A lot of people think that within that container you would be running multiple things. The ideal is that you run one thing on it, and then you could put multiple containers together to create the application. But if you do that, what happens is your engineering team, your developers can create their code, they can run it in this container, and when they pass it on to development or pre-production or all the various different areas, they will utilize the same containers to run the application in, because those containers is what's also used to when they deployed into production into their Kubernetes clusters, which means you actually develop on a consistent environment, and it goes throughout the whole pipeline as such. And you get a lot more consistency through it, and you don't get the traditional where everybody says, well, it worked on my machine, but it doesn't work on that machine. And I think too many times, what people do is they want to get too quickly too far. They want to, instead of walking, they want to start running straight away. And if you're an athlete, if you don't do a few stretches and you warm up, you're gonna pull a muscle, or you're gonna have a problem later. So it's the same in technology. Sometimes when you just jump into the deep end, you might go, I've got no idea how this works. Maybe it looks too complex, or you burn your hands and you go, oh, this didn't go that well, and then you walk away from it. But with container technologies and Kubernetes, when you start looking at these, a good way is to start small, evaluate it, play with it. You can run Docker containers on your laptop. You can run it, as Jonathan said, on a Raspberry Pi. You can. One of the nice things that I don't think we really mentioned that is when you start talking about containers is that they're portable. I can create them on my laptop and upload them to a registry, and then someone else can download it to their laptop and use it on their laptop. It's the same container, that runs the exact same way as it would have run on my environment. And start playing with these technologies and experiment with it. Build an image. Some people just start using it, and I think that's a great way to just start using it. Don't try and jump into the deep end and start building your own containers straight away. First, just use them, see how they work. What is an entry point? What is the entry point script? How does these things work? How do they handle storage? Because you'll start hearing people talk about persistent storage. And the ideas that you can start a container and just throw it away. But what if that container had state and storage and something that you need to keep? How do you handle databases, networking? Start small, just play with it on your laptop. And then before you know it, you'll find that, hey, this is easy. And then you move on to the next part. And before you know it, you start jumping into the world of Kubernetes where, there's a whole new world out there for you on how you can orchestrate all these things. And you talk about, people are quite familiar when you talk about monolith applications. A lot of these, it's big applications. If you change a piece of code in one place, you're kind of a bit worried what might happen in another area because, it's so tightly integrated. And what container technology allows you to do is to kind of decouple these things. And that's where you start hearing people talk about microservices, creating microservices architecture. And fundamentally, if you look at below that, you'll find that you'll see technologies like containers, Kubernetes, and all being used behind it to help you orchestrate and create these applications. Now, if you need to make a code change, you'd update one service, which could be just one container image that you update and you deploy that and your upgrade is complete. You didn't change the whole application.
Yeah, and you made a really good point there, and I'll bring in Paul Scott Murphy here next, but you made a really good point about only having to fix one small little piece of the puzzle. Instead of, like, if you think of the old monolithic application, you start changing things, it's like Jenga. You're going to pull out the wrong block and it's all going to come crashing down. And then you're going to have lots of very, very unhappy people on your hands calling you up at 4 a.m. on, Saturday night. That's not good. But if you can go and just fix one little thing, well, then you just change the litany, if you will, and everything works fine, or at least it should. So it's you're embedding more durability into the system. And it's also very efficient. I think that's the key, is that these applications do lots of different things. And if you break those up, I think you were the one saying that, Anton, into individual containers that do one very specific thing, then it's nice and tight and robust and should be fairly easy to debug that one little thing that does its little job. But in the old world, the big monolithic application that you would get from the major vendors, that's a very complicated set of code that's been compiled and is now running on your server somewhere. And getting to the bottom of that is like, good luck, buddy. It's not going to happen. So we're making things more efficient, and we're making things faster, and we're making things more durable, I think is the real key. But with that as a segue, let me throw it over to Paul Scott Murphy from WANDisco, also doing some very cool stuff with live data, the live data platform. I love that. Paul, tell us a bit about yourself and what you think about the world of containers.
Yeah, hi, Eric, and it's great to be back on the show. So thanks for having me on for today. Love to talk about what WANDisco is doing in the world of containers and all things state in the cloud as well. And there's been some great points made by Jonathan and Anton around this through the discussion so far. One of the ways we like to look at container technology and orchestration platforms around that is that it's really a progression towards cloud-native architecture. Of course, Kubernetes emerged from Google's own development and then became a part of the cloud-native computing foundation. And that's only recently, right? Containers themselves are only first available for use around 2008. And Kubernetes, of course, was first released in 2014. So not that long ago. It's understandable that people are still getting their heads around what this means and what they can do with the technology. But in assessing that and whether or not it makes sense to think about Kubernetes as a platform, you've really got to look at the standard, or do the benefits outweigh the risks? What are the benefits of using a platform like Kubernetes? What are we doing around that? There's plenty of organizations that are happy to talk publicly about their view on this looking back, having adopted Kubernetes, why they took that direction and some of the benefits that they gained in doing so. There you'll hear conversations around things like cost reduction, right? The optimizations that can be made from better packing in your compute across a range of machines that are deployed in the cloud, whether that's virtual or physical, compared to the traditional VM-based virtualization. Kubernetes offers greater advantages there, but also in terms of scalability, right? By having an orchestration platform that is declaratively based, the scalability of these systems can be of greater value than you'd get by crafting that by hand. Taking advantage of how Kubernetes allocates resources across infrastructure gives you better scalability there. But the hidden benefit, I think, that underlies all of this is one around standardization. The fact that organizations, although what we're talking about here is moving from one type of thinking about infrastructure to another, that they don't need to think about the infrastructure in the future. Right? They're just standardizing on Kubernetes. It means they can learn from one another. You can learn as an organization from what your peers are doing, rather than building that on a custom container orchestration platform yourself, one you might build, or an outdated one. Doing that on Kubernetes today means that you're taking advantage of what your peers have done, what they've learned, and how they've been able to improve over time as well. So besides cost reduction, stability, scalability, the standardization, I think, is a really unsung benefit of concentrating efforts around Kubernetes as a platform that may not be obvious to organizations today.
Of course, out of the box, Kubernetes, as designed, was stateless. So those little pods, they don't really know about state. And to describe state for the layman out there, I'll use an example, and one of you correct me if I'm wrong, but think about when you're going online to shop for something and you start putting things in your cart and then you want to go to checkout. Well, that's a very definite change in state, right? I was shopping, now I'm buying. And I want the application to know what it is I'm going to buy. And then I put in my credit card information, et cetera. So this is where you have stateful changes. And Kubernetes out of the box originally was stateless. Now, I know that there's been some work at the Linux Foundation, or the Cloud Native Foundation, I think it is, to work on that and to enable stateful applications. But the point is the state resides in an application somewhere. And kind of what you were hinting at there, Paul, is in a distributed environment. When you distribute the compute across lots of different nodes, for example, you really need to be mindful of these kind of things, right?
I think you're absolutely right. The interesting part around Kubernetes is that going back about 2 years, that they introduced this notion of what's called a container storage interface. And that's an abstraction around how application workloads access storage. By abstracting the access to storage, it opens up opportunities of how you can enable applications to do that differently, or allow the underlying storage infrastructure to be swapped out and used by applications in a common manner, giving you the flexibility to move your workloads into new environments or take better advantage of new services that emerge around storage and state over time.
And I'll bring Jonathan Johnson back in from Du Jour here to kind of explain all this stuff. So states, we're talking about state and understanding state. And there are some new things, as Paul just mentioned, from WANDisco coming out of the pike, which are really interesting, which are going to give us even more flexibility for how we accomplish business objectives. Because at the end of the day, the business person doesn't care how something gets done. He or she just wants something to get done. And so when you look at these distributed architectures and distributed computing, well, you figure it was probably over 20 years ago now, 25 years ago, that companies like Yahoo and eBay and some of these other folks were very intently focused, in the open source community in general, on scale up, on being able to handle peak throughput, like on Black Friday, for example. When you get all these people coming into your website, you want to be able to handle that. You used to have to just basically buy enough servers to handle peak and then use only 20% of them for the rest of the year. Well, that's not a very efficient way of doing things. So we've been trying to work on this for a long time, but now with Kubernetes, it seems to me we're finally there where we can scale up and scale back down as needed. And that's just fantastic stuff, right? Take it away, Jonathan.
Yeah, and how that works is the aha moment for the engine of Kubernetes and what it does for, often what I do is I talk to developers. How do I get my applications to run on this thing called Kubernetes so I can eventually get it to my customers, right? How do I do that? How does Kubernetes work? And what I often tell them is, look, Kubernetes is a state machine and it's trying to keep things in balance. You tell it what the balance is and it will maintain that state for you. I often think for visualization of this is imagine hopefully many people have seen the videos from Boston Dynamics where you get the engineer with a hockey stick and he's pushing against one of the robots. It's amazing. I don't know if everybody saw the dancing robots video.
Crazy.
It happened on a holiday break. That was amazing. But with a hockey stick example of pushing that robot to the point where the robot staggers and then sometimes it falls Sometimes it doesn't. And then if it does fall, when it's down, how does it get back up to get back into that declared state? So the declared state is stay balanced and stay standing. Kubernetes is the same thing. You can say, I got a microservice here that needs to buy concert tickets. And I need 5 of them right now because there's only a little bit of traffic. And then when the concert venue opens up, I'm going to have a flood of people coming in trying to buy concert tickets. So that right there is a sense of pushing with a hockey stick. There's a balance of, there's a state of like, I want 5 microservices running. Now, when I start buying concert tickets, you've got a back pressure of traffic. So you talk about observability. So Kubernetes has layers of observability to look at the metrics, to look at how things are running. And if CPU or memory or IO becomes back pressured, becomes stressed, then Kubernetes has a series of controllers that will look at the state and look at metrics and say, oh, okay, I've got back pressure, I've got more traffic coming in. When that happens, I need to scale up. I need to have more microservices that allow people to buy concert tickets. There's actually a thing called a horizontal pod autoscaler. That's a fancy word, but it will scale your application up based upon back pressures. You as a developer say things like, very abstractly, it's saying like, when CPU becomes 50% loaded, I want you to scale up more. The imperative nature, the actual work of how to maintain that state is coded within these controllers within Kubernetes. So Kubernetes is really a collection of resources and controllers that are behind the resources. And all of these controllers are essentially making sure that your robot is standing and stable.
That's fascinating. That's really very interesting. And that's a good example too. I'll throw this over maybe to Anton to comment on. That's a great use case that Jonathan just mentioned. You've got a concert with a bunch of tickets. You want to distribute the purchasing of those tickets, but there is a set number of tickets against which you are selling. So you can't sell more tickets than there are, unless you're the airlines, in which case they did it all the time. Back in the day, they oversold. They could oversell a little tiny bit. I don't think that's happening these days. But can you kind of talk about the data side of that equation, Anton? Because it's an interesting use case. Again, you got a concert, you're going to flip on the switch on the website, maybe at noon when the tickets for Pink Floyd go live, for example. You know you're going to get a big rush. But how do you manage, A, the functionality side, but B, the data side, such that none of these nodes is selling something that they don't even have to sell? What do you think about that, Anton?
Yeah, that's a very interesting thing to keep in mind. And a lot of people, when they design these microservices, when you get into that point, you also need to think about it from the application point of view. How will you manage the data across these containers? Like, for example, it's easy to say, let's spin up 20 containers and they can handle the load. But if the application or the microservice within that container is not aware of scaling out or anything like that, it doesn't need to know how to scale out anything, but it needs to still be aware of that, then there'll be a problem. So the application, as a developer, as a designer of the application, you do need to take that into account. Like, how would you actually handle that within your microservice? And then you'll be looking at what's the type of database backend or the data store backend that you would be using. Because one of the other things you want to keep in mind is that you want consistency. You want to make sure that there's consistency throughout. You don't want to end up with inconsistent data. So there's a bit of a point there where, from a microservice point of view, from the application point of view inside the containers, that you do need to keep that in mind and actually then pick the right storage or the right database that you want to use to actually get that consistency for you. Then the containers can scale out, scale back in, because they all will push the data through to the right, let's say, storage backend that you're using.
Yeah, that's a great answer, folks. This has been a fantastic show. We've been talking to Jonathan Johnson of Dijure. That's D-I-J-U-R-E. Look him up on LinkedIn. Anton Els from HVR Software. That's hvr-software.com, I believe. And Paul Scott Murphy from WAN Disco.